Everyone, if you made it this far, you've come a long way, and I'm sure you're going to score a monster score on the August SAT. So, day 30 out of 50 now, and we're going to be working on more geometry and trigonometry questions. We're going to tackle 5 of them today, and we're going to start on this one over here. Okay, important. The figure's not drawn to scale, so you can't really estimate or eyeball it. Okay, so in the figure shown, line WZ and line XY intersect at point Q. YQ is equal to 63. So YQ is equal to 63. WQ is equal to 70. And WX is equal to 60. And XQ is equal to 120. What is the length of YZ? Okay, YZ, what is that? Well, we're gonna find out. So since these angles are the same over here and here, we are given, like, not directly but indirectly, that they are similar triangles because they need to have proportionate lengths in order to form the same angle. So therefore, we know that we can start a ratio here. We can say, if we're looking for line YZ, so line YZ over line YQ. So this line over this line is going to be proportional to WX, line WX over line WQ. Now we just plug in here and we get YZ, so we don't know YZ, so we're going to just keep it as YZ over YQ, which is 63, is equal to WX, 60, over WQ, which is 70. Now we simplify this and we get YZ is equal to, put it in your calculator, 67 times 63. You're going to get a length of 54 units. So it's a fill-in question of hard difficulty. The very hard part about this question is knowing that the same angles imply it's a similar triangle. So you can find the proportionate length, set up the ratio, and etc. So just really know those little facts and you should be good. Next question. Triangle QPR is similar to triangle STR. The lengths represented by line ST, QR, PR, and QR in the figure are 14, 15, 20, and 25 respectively. What is the length of SR? Okay, we're going to fill in these lengths. So ST is 14, ST 14, QP 15, QP 15. Now we have PR 20, PR 20, and then we have QR 25, QR 25. Now it's asking for the length of SR. SR is this length. So once again, we're going to set up a proportion, a ratio. So since we know they are similar triangles, we can do the same thing we did last problem with those triangles. So, but these are kind of flipped, so don't get confused. This side is proportional to that side, proportional to that side. So whenever one side increases, it's going to increase by the same amount. Okay, so we know that line SR is what we're looking for over ST, what we have, is equal to line, so if this is SR, it has to be proportional to QR over QP. Since we chose ST, we have to choose QP as well. And that's going to give us SR, which what we're looking for, ST, which is 14, is equal to QR, which is 25, over QP, which is 15. So we're going to get SR is equal to 25 times 14 over 15, which is going to give us 350 over 15, and an answer of A. This same deal as the last one, just know your rules and you should be good. Practice a lot of proportional or similar triangle questions and you're good to go. Next question. Two nearby trees are perpendicular to the ground, which is flat. One of these trees is 10 feet tall and has a shadow that is 5 feet long. At the same time, the shadow of the other tree is 2 feet long. How tall in feet is the other tree? Okay, so we're only given one fact about the other tree. But let's draw out the tree we know a little more about. So 10 feet tall for the first tree. And it creates a shadow that is 5 feet from the ground. And now we have another tree that is 2 feet tall, so much shorter. Or not 2 feet tall, sorry. A tree that creates a shadow 2 feet from the ground, or 2 feet long. And we need to find how long this is. So another triangle question. You just make the triangles. Okay, so we know that this side is always going to be 2 times this side. This side is going to be 2 times that, so we're going to get 4. If you want to do it in the way we solved the other sides, you can do 10 over 5, which is this side over this side, is going to be equal to our unknown over 2. And then you simplify this. This is 2 is equal to unknown over 2, and then 4 is equal to the unknown, and that's your answer. Both ways are right to approach it, but just pick one, stick with it. Not too hard of a problem. And yeah. Okay. Second to last problem. A right circular cylinder has a volume of 377 cubic centimeters. The area of the base of the cylinder is 13 square centimeters. What is the height in centimeters of the cylinder? Okay, the area of the base of the cylinder. So we know that the base of a cylinder is what? A circle. Okay, a circle. The area of a circle is equal to pi r squared. So, and we know that the volume of a cylinder is equal to pi r squared times the height. And we know that in this scenario, it's equal to 377 cubic centimeters. We're looking for the height only though, and we're given the area of the base. So if we know the area of the base, which is pi r squared, we know that this is going to be equivalent to 13 and times h, which is 377. Now we divide both sides by 13, and we get h is equal to 29 centimeters. That's going to be your answer, and put it into the computer. Not too hard at all. Okay, last problem for the day. The figure shown is a right circular cylinder with a radius of r and a height of h. A second right circular cylinder not shown has a volume that is 392 times as large as the volume of the cylinder shown. Which of the following could represent the radius r in terms of r and the height h in terms of h of the second cylinder? So we know that the volume of a cylinder, once again, is pi r squared times h, and that's the volume of this one over here. And we know that the new cylinder is 392 times the volume, and it's big H and big R, pi big R squared times big H. So we need to plug in these values for all of them and see what we get. So 392V must equal 392 pi r squared h. So we're going to see if we get that. If this is satisfied, that's our answer. So 392V, we're going to plug in 8r and 7h to begin with. So we get, for this one, pi times 8r squared times 7h. And we get 64 times 7, which is 448 pi r squared h. These are not equivalent, so this is going to be incorrect. Now we're going to try again down here. So we know 392V is equal to pi times r squared, 8r squared times 49h is equal to, so 64 times 49 is going to give us 3,136 pi r squared h, which is way off. That's incorrect. We're going to do it again. 392V is equal to pi times 7r squared times 8h, which is going to be equivalent to 7 times 7 times 8, 392 pi r squared h, which is equivalent, and that's our answer. Okay, thanks for joining me again on this video. Keep on watching these if you have time, and it's really going to show improvement on your next SAT. And I wish you guys all the best of luck. See you on day 31.